All right, so here we go with another chapter, a new one for us. The properties of exponents is going to be the first lesson that we talk about in this chapter 6. Chapter 6 deals with polynomials and sometimes their functions as well. So today we're going to start it off slow, working with monomials. That is a form of a polynomial. And in the 6.1 lesson, you'll know how to add, subtract, multiply, and divide these monomials. And I hope that you understand the process of each property. And if you would like, there is a note guide available on Schoology if you want to print that off before we get started. I do think it would be beneficial because it will organize these properties, which tend to be something that you want to reference frequently. So it might be a nice thing to print off for yourself. Okay, let's get started. If you're using the note guide, here's how you need to do this. The property name is one column, description another, and we'll have room for the examples. So the property name is going to be listed at the top of the flip chart, and there you see product of powers. Go ahead and put that in the first space that you see under property name, product of powers. And in the second one, you're going to put the following. I have the description here as a to the m times a to the n equals a to the m plus n. Go ahead and write that in the description box. And then finally, you're going to write the examples across from that. And I've given you as much space as I can for each one. So if you see you have 3 examples, make sure you're writing small because you're going to have to fit 3 examples in that one box for product of powers. So our first example looks like this. We have x to the 5th times x to the 7th. And we know that according to the description, we're going to take that 5 and that 7, and it looks like they want us to add. So I'm simply going to say 5 plus 7 equals a power of 12. So our base x is to the 12th. Final answer is x to the 12th. Next example, example 2. Now we have 2 to the 4th times 2 to the 5th. And it is really tempting to say 4 to the 9th, and that would be incorrect because the 2 is acting as a base, and you're going to carry your base. We do not multiply that. We're working with the exponents instead. So we're going to take that 2 to the 4 and that 2 to the 5, and we're going to follow the rule, which is to add. And so this final answer is going to be 2 to the 9th. So once again, the 2 is acting as a base, and we're going to carry that base. Now, since it is a number, we can use our calculator to simplify this even further, and we should. So 2 to the 9th actually turns out to be 512. And you simply go to your calculator, use your power key, and power up 2 9 times. Next example, example 3. This one gets a little more tricky. Make sure you're paying attention to the details that I'm pointing out, because as we move along into the 7 properties that we have, sometimes it can be confusing. So the sooner you can straighten out really what's going on with each one, the better off you are. In this example 3, I'm going to actually separate everything and write it out for you so that you can see what's going on here. I have the 7 times the negative 3. Everything's multiplying, right? We're side by side. Multiplication, because we have a set of parentheses times a set of parentheses means multiplication. So the numbers go together. 7 times negative 3. I'll even put this in parentheses so visually it looks like something you're familiar with. And so that gives us a negative 21. What's the next thing I have to put together? I have an a to the 6th times an a. Do you happen to know what that would equal? Well, that's going to equal a, believe it or not, to the 7th. And the reason for that is because this a that doesn't have an exponent there is understood to have a value of 1. So a common mistake is to just say a to the 6th, but this is a to the 7th. And finally, let's take care of these b's. We got a b to the 4th times a b to the 5th. And that gives us b to the 9th. So our final answer looks like this. Negative 21 a to the 7th, b to the 9th. My biggest caution here is that you will actually multiply the numbers, but you're going to add the exponents. And that is where, if you're not paying attention on any test or quiz, where you might have an issue, because you've really got to be focused on the fact that you're doing two different operations in the same problem. The second property is the power of power rule. So here we go with the power of power rule. It looks like this. A to the m, all that raised to the nth power, equals amn. So what operation is implied here when you have an m and an n? We know that that is multiplication, right? So we're going to multiply the exponents. When we have a power of a power, we're going to multiply the exponents. Let's take a look at what we have in example 1. In example 1, we have y to the 5th powered out 4 times. What does that mean? That means I'm going to take that y to the 5th, I'm going to multiply it by itself 4 times. I'm showing you this so when you're on a test or a quiz, you understand how we got to the rule of multiplication. So in case you forget, with all these properties that we're learning today, what's going on with each one, you can perhaps look back at this and say, okay, what does it mean? It means that if I power that out 4 times, that y to the 5th, I actually end up adding the exponents, which is 5 plus 5 plus 5 plus 5, which is, of course, 20. And a fast way to add 4 5s is to multiply. So there you have it. That's the reason why we multiply 5 times 4 to get our 20. Example 2, we have 2c to the 7th powered out 3 times. What's the conflict here? You've got a number mixed with variables. So this is what's going to happen. We're going to go ahead and take that 2 and we're going to power it out 3 times. And we're also going to take that c and power that out. I'm sorry, I said 2 times, but 3 times. So 2 to the 3rd and c 7 to the 3rd. What would that equal? It's real tempting for students to say, oh, that's easy, 6c to the 21st. Not so easy and not so fast, because it's not 6. This 2 to the 3rd really means 2 times 2 times 2. So the answer here is 8c to the 21st. And that is the answer. Now why did that happen? Because we are going to take the number and we're actually going to power out the number. Whereas in the exponents, we're going to actually take the exponents and we're going to multiply them. So you see there's different rules once again, and if you're not on top of your game, you're going to make mistakes of multiplying everything. You don't multiply everything. You power the number and you multiply the exponents. Now I'm going to bring you back to another slide here where I tried to point something out to you right here. The fact that once again we have 2 things going on where we multiply the numbers and then we add the exponents. So you see how we have different things going on. Numbers are treated differently from the exponents, is what I just said. So keep that in mind as you work, because that will be a big, big issue that you're going to want to make sure you're on top of. Here's a you-try for your example 3. You've got a negative 10, p to the 3rd, q to the 2nd, all that to the 4th power. Go ahead and press the pause key as you compute that. Come on back and I'll have your answer for you. Well, you knew anything to the even power, if it's a negative sign, is going to come out to be a positive. So this is a positive number. And then 10 to the 4th, you add 4 zeros to your problem, so 10,000. Multiply that p to the 3rd times 4, and you get 12, and then 2 times 4 is 8. I hope you got the right answer. Power of products is our next property, and we have the following description of parentheses ab to the nth power. And what does that equal? It equals a to the n, b to the n. That is because I have the parentheses here, and so the parentheses protect the fact that not only the a gets the nth power, but so does the b. So in example 1, we have x to the fourth, y to the third, all of that raised to the second power. So the 2's going out to the 4, and the 2's also going out to the 3. In this monomial, the answer would be x to the 8th, y to the 6th. Now, because this is a monomial and you don't see an addition or a subtraction sign in between, we can go ahead and distribute that 2 to the 4 and to the 3. And some of you might be confused when I show you this next one that I've talked about over and over and over again. No, no, 1,000 times no. It would not follow that if I had a, see this plus sign? There's a plus sign. Oop, that's a plus sign. If I have the a plus b and all that's being squared, you cannot, no, you cannot distribute that 2 out there. The plus sign, or if it was a minus sign, if I had a minus b squared, it does not equal a to the second minus b squared. No. What this means, in case you're wanting to know, oh, well, what would it be? What would it be? That means this, a plus b times a plus b. And when we FOIL, we would get an answer of a squared plus 2ab plus b squared. So I want to tell you once again, do not distribute a power to anything that's not a monomial. All right, I hope you got that. Now in this next one, let's see if you can come up with the description. When it comes to quotient of powers, what would you say if I asked you to come up with the rule given, oh, I don't know, a to the fifth over a to the second? That would mean I have a times a times a times a times a over a times a. A over a, value of 1, a over a, value of 1. What did that conclude? That I would have a to the third left over. Let's try another one to see if you can catch that rule. What if I had b to the sixth over b to the fourth? Let's see what we would get. I'd have 6 b's in the numerator, and then I would have 4 b's in the denominator. And what would you be left with? It looks like you would have b squared. So do you know the rule yet? Let's see if you figured it out. When it comes to quotient of powers and I have a to the m over a to the n, it would be the same as saying subtraction. And wouldn't that be true? Let's take a look at that and see. If I had this a to the fifth over a to the second and I subtracted the 2, I would indeed get the 3. Or the 6 minus 4 would give me the 2. So there you go, a nice easy way to go ahead and compute the quotient of powers. So what would you say if I had 5 to the 7th over 5 to the 4th? Now in this problem, you can take a look at the power rule over there, and let's see what we would get here. We would get, well, 5 to the 7th minus 4 would give me 5 to the 3rd. If you're not sure how to do that, go ahead and map out 7 of the 5's and 4 of the 5's on the bottom and see how the 1's cancel, and you'll get that 5 to the 3rd. Next one, x to the 17 over x to the 3rd. Again, I don't have to draw all these out anymore. I can just go ahead and use the rule. If I have x to the 17th and I subtract the 3, my final answer is x to the 14th. Another way I like to look at this is I have 17 x's up and 3 x's down. I have more x's up than down by how many? And the answer is 14. That's a nice way to look at that problem for when you get to something like we have here, this example 3, where I have 18 a to the 4th, b to the 2nd, c to the 3rd, all over 12a, b to the 6th, c to the 2nd. This is a pretty easy problem if you just go ahead and isolate in your mind what's going on. First, let's isolate the number that we have here. So we have the 18 over 12. Now back in 6th grade, if I were to ask you to reduce 18 over 12, what would you get? Well, you know you would get the 6 goes into the 18 3 times, and the 6 goes into the 12 2 times. So 3 over 2. As far as the a to the fourth and the a to the first, that's to the first power right there, you would simply take that. You have 4 a's up, 1 a down. You have more up than down by how many? By 3. And our b's, where do you see the most, in the top or the bottom? The 6 is definitely bigger than the 2. You have more in the bottom by how many? Let me map that out for you on how that would look. That would be b over b, b times b over b times b times b times b times b times b, right? And I would cancel these two out. What would I be left with? B to the fourth. I'd have 4 left over. And finally, with our c's, we're going to have more up than down by 1. Final answer is 3a cubed c over 2b to the fourth. With negative exponents, we simply have to remember this rule, that a to the negative 1 equals 1 over a. What that means is that since I have a negative exponent, it's ambiguous. We don't really know what to make sense of it. So to compensate that, we send it to the denominator, that exponent, but we send it positive. So it looks like this. If I have, in example 1, 4 to the negative 1, what I would do is simply rewrite this as 1 over 4 to the positive 1. And so your final answer is 1/4. And now it makes sense to us. We all know what the value of 1/4 is. So that is the reason why we change the rule up a little bit and take that negative exponent into a positive, but we have to send it down. So when we have in example 2, 8 to the negative 6 and 8 to the negative 4, same idea applies here. The only difference is if it's up, it goes down, and if it's down, it goes up. So if you have 8 to the negative 6, we're going to send that down to 8 to the positive 6. So what do you think will happen with that 8 to the negative 4? You'd be correct if you thought, all right, well, we're going to bring that up, 8 to the fourth. Now we're not done yet. Now it's time to apply our quotient rule. So you have 8 to the fourth and 8 to the sixth. You have more down than up by how many? You have more down by 2. And so that would be 1 over 8 squared. Now you're wondering, why do I have an equal sign? Because when it's a number that we can evaluate, our job is to do that. So the evaluation of 1 over 8 squared is 1 over 64. Our third example is just incorporating all these rules and making sure we understand them. So you see we have this negative 2, and because the 2 is negative, a lot of people think that we should send that 2 to the denominator. But if you really look carefully, the only time we send something to the denominator is if the actual exponent is negative. And in this case, it's not the exponent that's negative for that 2, it is the number itself. So let's go ahead and keep that negative 2 up because nothing will send it down. And how about this a to the negative 3? That's going to go up. Instead of a to the negative 3, we're going to actually send it up as a positive 3. So we'll have a to the 4 plus 3 is 7, a to the 7th. And on the b's, do I have more up or down? And I have more down by how many? By 1. So this is our final answer. So once again, negative exponents are always positive. So I want you to probably make a note, something like this, that we cannot leave exponents negative. So make sure you're aware that you cannot leave exponents negative. You have to make them positive. All right, that's it. This next slide is a piece of cake because very simply we got a rule here that says, hey, anything to the 0 power is 1. So a to the 0 power is 1. Only exception is 0. 0 itself cannot hold a power of 0. So with that in mind, let's go on real quick to number 1, example 1. What is 5 to the 0 power? Well, if you press that on your calculator, 5 to the 0 power will come out 1. Your calculator knows that anything to the 0 power is 1. And I do mean anything. If we take the word anything and we put it to the 0 power, it's holding a value of 1. Now let's incorporate that in example 3 and put that in our negative 4x to the 0 y to the 7th over y squared. If we go ahead and put this in an example, what happens to this x to the 0 power? What does it equal? It equals 1, right? Everybody thinks it's 0. It's not. Anything to the 0 power is 1. And we still have to contend with this y to the 7th and this y to the 2nd. So I have more y's up than down by how many? You'd be correct if you said 5 because 7 minus 2 is 5. And also, I just now have to evaluate what a negative 4 times 1 is, and it's negative 4. So negative 4 y to the 5th is my final answer. And finally, power of quotients. Here's what it looks like. If I have the fraction a over b, and all of that is to the m power, then I'm going to say a to the m over b to the m. An example of that would be if I have c to the 4th over d to the 9th, all that to the 10th power, I'm going to distribute that 10 to the 4, and I'm also going to distribute it to the 9. So our final answer for example 1 would be c to the 40th over d to the 90th. That's all you have to do there. Now look at this one. Notice I have a negative 1 there. Anything to the negative 1 power will cause what to happen? Well, let's take a look at what happens. If I distribute this out, it's going to be x to the negative 3, and that y to the 7th will now become y to the negative 7th. What's the negative power rule? If it's down, it goes up. If it's up, it goes down. So y is now y to the 7th in the numerator, positive, of course. We changed that sign. And the x became the positive 3, but in the denominator. I cannot combine unlike terms, so don't try to subtract here. You cannot. This is our final answer, y to the 7th over x to the 3rd. And in example 3, we have a to the 2nd over b to the negative 4, all to the power of 3. Let's power that 3 out, and I have a to the 6th over b to the negative 12th. What do I do with that b to the negative 12th? I have to bring it which way? In the opposite direction. And now not only is the a in the numerator, but now the b just became a member of the numerator. And so a to the 6th, b to the 12th, final answer. So let's go and do a standardized question now, incorporating some of the skills that we've learned today. The first thing we've learned, I'm going to highlight in yellow here, and that is that x squared and x to the 5th can be put together. And just how do we put them together? What would they result in? Well, that's actually saying x to the 2nd times x to the 5th. And so we know that that's the side-by-side rule, and that would give us x to the 7th because we add those. So we've got inside here x to the 7th, y to the 3rd, over 2 to the negative 1, all of that to the 2nd power. Next thing we've got to do is distribute this 2 out. We're going to incorporate that quotient rule that we just learned, and that would give us x to the 14th, y to the 6th, over 2 to the negative 2. Now, if you're not sure what to do with this situation down here, look at your answers and see if there's anything you can eliminate so far. Well, we didn't get x to the 20th or a y to the 6th. We didn't get x to the 9th or a y to the 5th. We have the 14 and the 6 in the next 3, so it's either going to be C, D, or E. So we're going to have to take this 2 to the negative 2 and see if we know what to do with that. What do you do with negative exponents? If it's down, it goes up. If it's up, it goes down. It's down, so we're going to bring that up. So that means that we're going to have 2 to the 2nd power. Remember, when you bring it up, you change that negative to a positive. The x was already up, so I'm going to keep it there. The y was already in the numerator, so I'm going to keep it there. So now I simply have to go ahead and evaluate what 2 squared is. 2 squared is 4. And so it looks like my final answer is going to be E, 4x to the 14th, y to the 6th. So let's go ahead and wrap up this lesson on properties of exponents with monomials. The challenge to this lesson is knowing the rules of the properties. Some of this is just good old-fashioned memorizing. So keep that chart in front of you. We'll be working a lot with it in class, and eventually in due time you will have those properties down. Negative exponents send the power in the opposite direction when it's in the fraction. So keep that in mind. And finally, any number to the 0 power is always a value of 1.